In mid-18th century Britain, the unyielding cycle of the machine replaced that deeply human rhythm. Industrialization shattered the historical definition of design, moving beyond a simple increase in manufacturing speed to create a permanent gap between the architect and the object. A machine operates on rigid repetition. It cannot pause to adjust a curve, refine a texture mid-strike, or exercise creative autonomy. Because a power loom or a steam press lacks spontaneous creative judgment, every single aesthetic and functional choice has to be mapped out and finalized before the power is ever turned on. This mechanical limitation created an entirely new professional class, the industrial designer. An industrial designer is a specialist who dictates exact forms, material specifications, and assembly protocols from a desk, entirely removed from the factory floor where the physical labor happens. The historical standard of organic making gave way to a rigid system of planning. This epistemological split demoted the physical creator to a mere machine operator, executing someone else's blueprint. Meanwhile, the designer was elevated to the architect of mass reality, defining the physical environment for millions of people they would never meet. The engine driving this separation was thermal energy. By extracting coal and refining the steam engine, society severed its reliance on muscle, wind, and water power. Industry redirected this immense thermal output to process raw materials, specifically iron. In 1856, the Bessemer process arrived. By blasting compressed air through molten pig iron, it violently oxidized and removed impurities from the metal. The result was steel that was cheap, abundant, and possessed immense tensile strength. This diagram illustrates the structural difference. On the left, traditional masonry, stone and brick, relies entirely on massive weight and compression. On the right, a slender steel I-beam handles the load using high tensile strength. Steel allowed structures to support exponentially more weight using a fraction of the physical mass. This single material breakthrough liberated architects from thousands of years of structural constraints, fundamentally changing our modern skylines forever. Walls no longer needed to be thick and heavy to bear the load of a roof. The steel skeleton did the work. Material science now dictated design. Buildings could grow upward into skyscrapers and outward into massive spans without collapsing under their own weight, forcing the invention of entirely new architectural typologies. This new architecture arrived exactly when a severe demographic shift demanded it. Urban populations were booming, requiring massive civic spaces on a scale humanity had never attempted. Architects invented vast factory floors, soaring train stations, and sprawling exhibition halls. The ultimate proving ground for these new spaces was the 1851 Great Exhibition in London. Joseph Paxton proposed a concept for the main exhibition hall that seemed physically impossible to build within the tight 9-month deadline. Looking closely at the repetitive structural grids in his sketch, the underlying logic emerges. Paxton relied on prefabrication. Instead of building piece by piece on site, standardized, modular iron and glass components were designed and manufactured in factories, shipped and rapidly bolted together. The final execution of the Crystal Palace was an engineering triumph, achieving a staggering scale and an unthinkably transparent facade. The Crystal Palace functioned as a giant, scalable machine, prioritizing modular assembly over traditional permanent mass. The structure served as modern design's ground zero. It proved that standardization and high-tech engineering could create spaces that traditional masonry could never achieve. While steel redefined the macro scale of architecture, the micro scale of consumer goods felt the earliest impacts of mechanization in the textile industry. A rapid succession of technological leaps, beginning with the flying shuttle in 1733 and the spinning jenny in 1764, mechanized the weaving and spinning process. These machines produced an exponential multiplier effect. A single operator could output the equivalent work of 20 hand weavers. On the new factory floor, the human worker's role was reduced. They no longer created, they merely fed and maintained the primary asset, the machine itself. The economic upside was massive. Textiles and household goods became radically cheaper, highly accessible, and were produced in staggering volumes. But this efficiency carried a hidden cost: homogenization. To keep the assembly line moving seamlessly, manufacturers stripped individual character, regional variations, and spontaneous artistry away from everyday objects. The mass production model successfully democratized consumption, but it triggered a severe aesthetic crisis, flooding the Victorian world with standardized, soulless goods. To compensate for this aesthetic degradation, early Victorian factory owners began slapping excessive, cheap ornamentation onto poorly made goods, attempting to mimic historical luxury. This dishonest design sparked a fierce intellectual backlash, spearheaded by theorists like John Ruskin. The designer William Morris weaponized Ruskin's theories. Together, they shaped the arts and crafts movement, a total rejection of the machine, and a desperate call to return to nature and the dignity of manual labor. The visual ideology of this movement was intricate, hyper-detailed, and defiantly anti-industrial. A pattern like this required intensely labor-intensive, handcrafted complexity to render the birds and flora. Early machines simply could not replicate this depth with any genuine soul. The arts and crafts movement elevated aesthetic standards and championed the worker. However, it was a romantic, doomed attempt to reverse industrialization. The machine was here to stay. Resolving the industrial crisis required designers to embrace the machine as a tool of aesthetic expression, rather than an enemy of craft. In 1919, the Bauhaus School in Germany established the definitive synthesis of this conflict. Their philosophy was radical. Instead of fighting mass production, they sought to merge the craftsman's soul directly with the efficiency of the factory floor. They introduced the machine aesthetic. Instead of forcing machines to mimic hand-carved history, they designed objects specifically optimized for the mechanical capabilities of industrial equipment. Bauhaus innovators like Günther Stölzl and Ani Albers applied abstract art and strict geometry to mechanized looms. This interdisciplinary approach stripped away useless ornamentation. They proved that functional, efficient, standardized form possessed its own inherent beauty. From the smartphones in our pockets to the modular skylines of our cities, modern design is the direct offspring of the Industrial Revolution, a permanent union between the brutal power of the machine and the deliberate intent of the human mind.